from our researchers' perspective, how to improve the road safety. There are like 4 dimensions. So the first dimension is to build safer roads. So the roads that can forgive drivers' mistakes. For example, we install the safety barriers for the highways so that if drivers make some mistake, they won't run out of the road. They will be protected by the safety barrier. We install the median to separate the traffic in 2 different directions to avoid the head-on collisions. And it can also prevent the high beam glare during the nighttime. The second dimension is to design safer vehicles. So for example, the vehicles that can prevent traffic crashes. You may know that in some advanced some of the advanced vehicles, they have the technology such as the emergency braking system, right? So the car will automatically brake for you, for the drivers, when the car is about to hit another object. So this kind of the advanced driving assistance system can help preventing the traffic crashes. And on the other hand, the safer vehicles means even if a crash happens, the vehicles can protect the drivers and its passengers. So the structure of the vehicle should absorb the energy of the crash, and so it won't hurt the drivers or the other people within the car. So this is second dimension. We need to design safer vehicles. And the third dimension is that we need to have safer road users. So this goal is mainly achieved via the education and reinforcement. So for example, the drivers shouldn't drive after drinking, and they shouldn't drive when they feel sleepy, and when they are after they're using certain drugs. So this is what the safer road users is about. And the last dimension is safety management. And this is what this talk is about. So basically, the safety management is to use a systematical method. Most of them are data-driven methods to improve the road safety. So there are like a few critical tasks in safety management. So generally, the first step is to collect the data. We have the historical crash data ready, and then we analyze those crash data to see what are the most dangerous locations in the road network. So this is called the hotspot identification. So once we have identified those high-risk locations, the second step is to analyze the crashes which occurred on those locations. And we also do the site visit to see what are the countermeasures we can develop to reduce the crashes on those high-risk locations. So this is the second critical task. It's called countermeasure development. So once we have developed the countermeasures and implement those countermeasures, we also need to evaluate how effective are those countermeasures. So then we have the third task is the before and after evaluation. So generally, in traditional safety management, we rely on historic crash data to evaluate the safety effectiveness. And it generally takes a long time because the crash are relatively rare events. To evaluate the change of the crash frequency properly, we need to have about 3 to 5 years data, and sometimes that's a really a long period of time if you want to know the effectiveness of your treatment more quickly. So in today's talk, I want to introduce to you how the big data can be used to empower the transportation safety management. So you may have heard of the term big data, which is a buzzword which has appeared more and more frequently in the research world. So what is big data? Literally, that means a lot of data, right? Usually the features of the big data can be represented by 3 V's. So the first V is the volume. So volume means they are increasing size of data. The second V is the variety. So we have a wide range of the data format. So traditionally, what we use, the data is structured data, like the numbers, the number of the crashes for each site, right? This is structured data. We can also, in the era of the big data, we also want to utilize unstructured data. What are the unstructured data? For example, the video data, the image data, right? Those are all, that's all examples of unstructured data. We also have the Twitter data, like in the text format, which is not tabulated, it's not structured, but after use a certain technology, we are able to convert those unstructured data into information, which we can utilize for safety management. So this is the second V, the variety. And the third V is the velocity. So velocity means the faster streaming speed of data. We are able to obtain the data in a real-time manner. So traditionally, when we are collecting the traffic data or the historic crash data, we cannot do that in real time. But in the world of the big data, we are able to do that. So the vehicles running in the cities, they are collecting the data and they stream those data to the cloud, and the system manager, they are able to use the data in the cloud to make decisions in real time. So below, this is a figure showing, so this is a figure I obtained from the Google Trends. So this shows the number of the searches of the big data. So you can see that as a proxy of the interest in big data. So you can see after 2011, the interest in big data increases dramatically. So what are the new opportunities in safety management with the big data? So there are like 3 critical tasks in safety management. I've introduced that before. So hotspot identification, countermeasure development, and before-after evaluation. So once we have the big data, how can those 3 tasks be conducted differently? So for example, the hotspot identification. Traditionally, the way to identify hotspot is like we collect the historical data, generally up to generally 3 to 5 years crash data, and then we analyze where are those crashes located at, and to cluster those crash data and to identify the high-risk locations. That's a traditional way and takes a long time, right? It takes 3 to 5 years to collect data, and we have to wait that long to know which locations are dangerous. But with the big data, we can use the alternative way to evaluate safety rather than relying on the crash data only. So we are able to detect the hotspots, the high-risk locations in a shorter period of time on a larger scale and with higher resolution. And for the second task, traditionally we rely on the crash data to make decisions, and we develop the countermeasures after the crash occurred. So this is more passive. So in the era of the big data, we are able to develop more proactive approaches. We can take actions before the crash occurs. We can take active actions to prevent those crashes. So this is for the second task. And the third task, before and after evaluation, in the traditional way, we need to collect, so after the treatment implemented, after countermeasure implemented, we need to wait another 3 to 5 years to collect statistically reliable data, sufficient data to make the evaluation, to see, to investigate whether or not those treatments are truly significantly effective. So it takes too long. And in the era of the big data, what we can do is we are able to evaluate the effectiveness of the countermeasures once they have implemented. So we can do the before and after evaluation much faster. Why can we do that? Because we do not purely rely on the crash data to make the decisions. We leverage other information collected by the vehicles on the road and the sensors on the road. So this is the whole framework of showing how the traffic safety management can be empowered by big data, and this is what this talk focuses on. So in this presentation, due to the time constraint, I will share with you 2 studies we have done under this umbrella, under the framework of the traffic safety management empowered by big data. So the first study is to use the video data to assess the safety performance of the road and to monitor the safety performance. So the big data we use for the first study includes the traffic video data. This is a large volume, and also it's unstructured, right? It's not like the crash frequency or the traffic counts. Those are structured data. This is unstructured data. In the second study, I will use the big data I will use is the connected vehicle data. So we use the connected vehicle data to identify the high-risk locations in the city. So those are the 2 studies I'm going to present. So the first study is the traffic video-based safety performance assessment and monitoring. So it's based on one of the articles that I published in Transportation Research, PASI. So the idea is to leverage the traffic camera data. So they are like a traffic surveillance camera installed in many locations of the city, and they are recording the traffic vehicles continuously. And so at that time, we are thinking how to leverage that information for the safety management. Can we really do that? Yeah, the answer is yes. So I will show you these videos to give you some basic idea, some intuitive idea. So you can see this at this intersection, we cannot observe any crash, right, in the video. But do you feel this is a safe intersection? The answer is no, this is not safe intersection. Why is that? Although we didn't observe any crash, but we observe a lot of the near crash situations where 2 vehicles almost hit each other, right? So we call those near crash situations conflicts. So from the video data, we are able to record how many conflicts are there, right? If we can use those conflict data, we are able to evaluate the safety performance of that intersection. because there are so many conflicts observed. So which means this is not safe intersection. So this is the basic idea of using the traffic camera data for the safety performance measure. So to assess the safety performance using traffic video data, we build a system, so which mainly comprises of 3 modules. The first module is to extract the vehicle trajectories automatically from the video data. So we have obtained the video data, and we cannot manually label all the vehicle trajectories, right? It's very time consuming, it's not automatic. So we leverage the artificial intelligence technology to extract the vehicle trajectories. So this is the first module. And the second module is that we need to convert those trajectory data into the risk data, right? So we need to identify the risk using the trajectory data. So we need to identify the conflicts or near misses, near crash situations once we have the trajectory data. And the third module is to leverage those conflict data to do the safety assessment. So 3 modules. So this shows you how we use the artificial intelligence to obtain the vehicle trajectories. So the first figure, the figure 1, is the original video data. And the figure 2, we use the KLT feature tracker to identify the key points on the moving objects. So you can see for a vehicle, generally the key points are the edges, right, of those vehicles. And in figure 3, we grouped those feature points, and we are able to obtain the trajectories of each vehicle. So here I showed you the examples of the trajectories for 2 vehicles. And figure 4, we can shows the distance between those 2 vehicles. We can also calculate the speed difference between them. Then we can use them to identify the conflicts. So once we have developed the artificial intelligence model, we are able to extract the trajectory from the video data. So this is one example. So we use this as an example because this video data has ground truth trajectory available. So the ground truth is obtained by manual labeling. So they hired a lot of people to manual label those vehicles. So we have the true trajectories. Then we compare the true trajectories with the trajectories we obtained from the AI, artificial intelligence models. So we can evaluate how good or bad is our performance, our model performs, right? And the results tend to be the performance is satisfactory. So this is about the second module of our system. So once we have extracted the trajectories of those vehicles, and how can we identify the risk? So here I show you one example of one type of the conflict, which is the rear-end conflicts. So if you look at this animation, so this illustrates one rear-end conflict. So you can see that those 2 vehicles almost hit each other. If the following vehicle doesn't doesn't brake hard, a collision will happen, right? So how to quantify the risk associated with this car falling scenario? So the metrics we use is called TTC, time to collision. And this is defined as a time required for two vehicles to collide if they continue at their present speed and on the same path. So mathematically, the TTC, the time to collision, can be calculated using this formula. So basically, it's the distance between the vehicles. So on the top, this is the distance between the vehicles divided by the speed difference of those two vehicles. So actually, it's a quite simple formula. So using this simple formula, we can calculate the TTC for each time step of this car falling scenarios. So if the TTC is less than a certain threshold, so generally we choose 1.5 seconds to 3 seconds, then we can see that a conflict is identified. So I show you two examples. So for the first example, on the left-hand side, this is the trajectories of those two vehicles. So the blue one is the leading vehicle trajectory, and the red one is the following vehicle trajectory. So basically, this is a case when the leading vehicle stops at the intersection, and then another following vehicle joins the queue. So we can calculate the TTC for each time step, and we find out there's one time step, the TTC is less than the threshold. So we can say we have detected the conflicts here. So for the second example, there are two vehicles leading and following. They move slowly when passing the intersection, and we can also extract their trajectories automatically, and we can convert their trajectory to TTC, and we can identify conflicts using a certain threshold once the TTC is lower than the threshold. So we can keep counting those conflicts, right? Encountered by any pair of the vehicles, and we can, if we accumulate them, we can obtain the total conflicts for each intersection. And you may know that how well are the conflicts able to evaluate the safety performance. So we need to, so generally we use the traffic crash data, right, to evaluate the safety performance. But here we are trying to use the conflict data to evaluate the safety performance. Is that really valid? Is that really a good way to do so? So the answer is yes. So because we find there is a great correlation between the conflict and the historic crash. So for that, we have collected the conflict data and crash data for two intersections, and we find out there is high correlation between the conflict data and the crash data. So with that in mind, we can use the conflict data, right, to evaluate the safety performance. And so this first, the top figure shows you the conflict count for each 5 minutes. So we can see that there are some time intervals with extremely high conflict count. So we can highlight those time intervals, and if we, for example, there is one time interval which has the highest conflict count, and we go back to the video to see what happened during that time interval, and find out there is a traffic spillover detected. So if so, this first figure. The figure on the left shows you the traffic cameras in Manhattan of New York City, and we can, if we can use those cameras to extract the vehicle trajectories and to convert those trajectories to conflicts, and to use conflicts to evaluate safety. Basically, what we can do is to have a citywide real-time traffic monitoring and a risk identification system, right? So we can identify where are the most dangerous locations in real time in the city. So this is one of the potential application in the future. So this is the first study. So the second study is to leverage the connected vehicle data to identify the hotspots on a large scale. So in the first study, what we use is video data, but there's two major shortcomings of the video data. The first one is that we cannot install the cameras everywhere because of the cost, because of the privacy issue. So the video data is only available at a few fixed locations. So this is first shortcoming. The second shortcoming is that the trajectory data extracted from the videos may not be accurate enough. So we may have the may have some noises which can lead to errorless mistaken results. Right? For example, the camera may vibrate and the lighting condition may change in different time of days, and that will bring noise into the video data, and that will eventually affect the performance of our system. So one possible solution to fix that is to use the connected vehicle data. So first of all, what is a connected vehicle? So connected vehicles means that those vehicles, they are installed with all kinds of sensors like cameras, the LiDAR, radar, the GPS equipment, etc. And those vehicles, they are able to talk with each other. They are able to exchange their information, such as their speed, their positions, accelerations, etc. And it is expected that all new vehicles on the road will have the connected vehicle technology installed by 2023. So in a few years, a lot of the vehicles on the road, they are connected. They are able to talk with each other. They are able to exchange information. So the connected vehicle data we use is from a large experiment, real-world experiment from Michigan. It's called the Michigan Safety Pilot Model Development. And there are like over 2,000 connected vehicles. And those vehicles, they are able to, they have the GPS devices. So by using the GPS device, we can know the locations of those vehicles, right? And they also have this kind of the front camera. So this is a technology provided by Mobile Eyes, and this front camera is able to detect the vehicle in front of it, and it's also able to measure the distance and the speed difference between the host vehicle and the leading vehicle in front of the host vehicle. So if you see that, if we can obtain the speed difference as well as the distance, what are we able to obtain? The TTC, right? So the TTC is basically the distance divided by the speed difference. So by using the data from the connected vehicles, we are also able to calculate the TTC, and with the TTC, we are able to identify the conflicts, and with conflicts, we are able to evaluate safety performance. So this is the data we have used, and this is 1 month connected vehicle data, and across 75 selected highways in Michigan. So this shows you the heat map of those connected vehicle data points. So the brighter means there are more connected vehicles traversing. The dark color means there are fewer connected vehicles. So we use the connected vehicle data, and we can successfully identify the conflicts detected by those connected vehicles. And if we plot that out So this is on the right-hand side, that shows the the conflicts detected by the connected vehicles on a daily basis. And on the left-hand side, it shows you the map of the crashes. So we can see that even with you can see, first of all, there is a great similarity between these two maps, the map of the crash and the map of the conflicts. And secondly, we can see that even with one-day connected vehicle data, we are able to identify some high-risk locations. For example, these two, right? So if you look at these two high-risk locations, you will find they always have a large number of the conflicts. So in a related study, so this is not connected vehicle data, but it's worth to mention. So there are a lot of like Uber drivers or Lyft drivers. They are using the mounted cell phone, and the cell phone actually has the sensors embedded. And so with the cell phone data, we are also able to detect the position of those vehicles, and as well as the acceleration speed of those vehicles. So by using the smartphone as a sensor, we are also able to identify the dangerous driving behaviors. Here we have two maps. The first one shows the distribution of the dangerous behaviors detected by cell phone, and the second one is the historic crash. So we can find out they have very similar patterns. So there are two takeaways from my talk. The first one is the traffic safety has become a critical public health issue, and every year there are more than 1 million people died of traffic accidents in this world. And the second takeaway is that the big data, such as video data, connected vehicle data, and the smartphone data, can be used to advance the traffic safety management, because it can monitor the safety performance continuously, and it is able to detect the hotspots in a short period of time on a larger scale. So that's all what I want to share, and thank you very much. Please let me know if you have any questions. Thank you very much.
Dr. Xie.
Hey.
Excellent presentation. There is a question, it's in the chat.
Oh, yeah. So I do see one question. So the question is, do you think that self-driving car will make roads safer? So I think so. I do think so. The reason is that the self-driving vehicles, they eliminate the human errors. So if you look at the crash record, the majority of the crashes, they are related with the human mistakes. So human drivers, they tend to make more mistakes than the machine. So if the majority of the vehicles, they are driverless, so that one will not be able to involve human errors. And I think a large portion of those crashes can be prevented. So this is for the first question. So the second question is from Diego, and the question is, can you explain how to determine the speed of the vehicles using the video method? Yeah. Yeah, great question. Yeah. So I'm not sure if you're asking about the surveillance camera or the mobile eyes camera. So if it's a surveillance camera, so the answer is that for every time step, we check the positions of the vehicles, right? So we know that after one time step, how far those vehicles move, and in pixels. But we are able to convert from the pixels to the actual distance in the real world. So basically, we obtain the pixel per second for those vehicles, and we can convert that into the meter per second. So that will be the speed of the vehicles. So there are more questions. The next one is, do you think R&D areas in car manufacturing companies could benefit from data scientists to develop technology that make their cars safer? Yeah, I do think so. Yeah, they are doing that right now. They are more and more advanced driving assistance system developed by those manufacturers, and they are installing the cameras, installing the LiDAR sensors, and all those along. Those sensors can collect the data of the vehicles around, right, the host vehicles, and by leveraging those data, they can develop systems such as the emergency braking system, right? If the vehicle is about to run into another object, the sensors will first detect that. It can do that faster than the human drivers, and the system of the cars can make a decision for the drivers, right, whether or not they should stop immediately. So if it's about to hit another vehicle, the sensors will collect data, and there is a model embedded into the system which just say, okay, it's dangerous now, we have to stop, right? So I do think the manufacturers, they can benefit from the data science. The next question is, do you use any device to drive safer, like the mobile eyes? I personally do not use any device like the mobile eyes, but I know in some advanced vehicles, they do have that features. Emergency braking system is one, and the other one is the blind spot detection system, right? If you want to change the lane, and there is a vehicle in the blind spot, and you will be warned. The drivers will be alerted, right? There's a you'd better not change the lane, right? There are many like advanced driving system like that nowadays. So the next question is, can you elaborate on the process of finding solutions and improvements once the safety risk or hotspot has been identified? Yeah, great question. So that really depends on what type of the hotspot that is, right? So if we find out the hotspot is related with a lot of speeding, then we should lower the speed limit, right? We should increase the reinforcement on that spot. So if it's related with a lot of, for example, left turns, so we find there are a lot of left turn conflicts. So we'd better at one intersection, we'd better install left turn like a protected phase in the signal timing. We are able to configure that, right? So they are like that really depends on what are the situations, and so the solutions are developed based on the all kinds of information we can get from that site. The next question is it possible to use the satellite instead of the camera in order to check the traffic? I think that's a great idea, yeah, to use the satellite, but there's a larger latency, like if you use the satellite data, and it may not be real time, and it's more difficult to process the satellite data. But really depends on the resolution of the satellite. So this next question is, how do we calculate the distance between two vehicles, which are further from the initial range of the camera as the distance shrinks? Okay, yeah, great question. So there's some methodology developed in computer vision. Because of the angle of the camera, right? So if the two vehicles are closer to the camera, the distance will appear shorter, but actually they are maintaining the same distance. So there's a transformation that has to be done before. So when you are converting the pixel to the real distance, you have to consider the angle of the camera. You have to calibrate that. So you have to do the spectrum transformation to account for this situation. So there's one more question. Sometimes the car crashes are caused by sleep deprivation or alcohol consumption. How do you differ those cases from the road problems? Yes, there are, yeah, as I said, there are many crashes that are related with the human factors, right? Human make mistakes and then crash happened. So this part of the crashes, first of all, can be prevented by education and the reinforcement. So it may not be able to improve that through the road design, but sometimes you can at least you can reduce the damage caused by the situation. For example, if you install the safety barriers, so even if there's one drunk driver, they drive carelessly and they run into the barriers, but the barriers can still, right? They can reduce the damage. If there's no barriers, the drivers may suffer from more severe injuries. On the other hand, the driverless cars, they are able to they are able to reduce this type of the crashes, right? So because those crashes caused by the human errors, that can be another possible solution. So I think that's the last question, right?
We still have some time, and if we can get some additional questions, certainly that will be great. So we have in audience, we had about 32 people watching the lecture, probably roughly about the same amount on YouTube as well. So we had a great attendance.
Yeah, there's one more. Yeah, that's one more question. So the question is, can we use the collected data to predict traffic in growing cities and use it for the designing of new road? Yes, I think so. Yeah, we can use that's what we are doing actually. Yeah. We do collect the data and we do predict the traffic in the future, yeah, and we plan for the future. and we bring the insights we learned from the past to design new roles. Yeah, that's what we are doing right now. Yeah. So any other questions?
Dr. Xie, let me ask you, it seems that the traffic signals and the marking of the roads is extremely important to avoid crashes. For instance, one of the videos that you show was extremely interesting, that it had a number of roads coming into an intersection, but I didn't see the road marked up, and it didn't seem to be a traffic signal in there. I mean, that's a big factor, isn't it?
Yeah, that's true. Yeah. So if the traffic is not regulated, right, there are some issues, right? The drivers do not know who has a priority. So they will either choose to wait, then both of them, they have experienced larger delay, or they choose to go, and then there may be a collision. So so for the better road design and the management, we'd better, right, to make it clear who has the right of way, and so that we can regulate the traffic.
You have one more question.
One more question. So I think to prevent crashes, we should educate people and make good traffic law to prevent it. I agree with that. Yeah, we should educate people. So at the very beginning, I show you 4 dimensions, right, to improve the safety. So the safer road users is one of them, right? But other than that, we also need to have safer roads. We need to design the road which can tolerate driver's mistake. But even if we make some mistake, it won't be that bad, right? We also need to have safer vehicles that can, once crash happened, that can absorb the crash energy and to prevent the people inside. So there are like there are 4 major dimensions we can work on to improve safety. But definitely, the education and the enforcement is one of the critical dimensions. Yeah. So there are a lot of because right now there are many crashes that are involved with human mistakes. Yeah. So that's an effective way to prevent crashes. Yeah. Educate people and enforcement and stronger enforcement. Yeah.
Well, I don't think that we are getting any additional questions at the moment. We have about 5 minutes left, and I wanted to remind the attendees, the audience, that if you have any further questions that you can come up with after the presentation, you can send an email to reyes@odu.edu, and we can certainly forward that message to Dr. Kun Xie, and he'll be able to answer that for you as well. Dr. Xie, thank you so much for the presentation. It was extremely interesting, very important subject for society. We appreciate taking from your busy time to do this for us.
Thank you, Dr. Asperas. Thank you, everyone, for listening.
Awesome. Have a great day.
You too. Take care.
Okay. Have a good day.
Bye.
Thank you. Bye-bye.